Have you ever taken a picture of a beautiful full moon with your phone just to be disappointed by a blurry, hard to distinguish image? Now, imagine trying to take a picture of the stars or taking a picture of the galaxy. Even with a good camera, sounds impossible, right? Then, how do scientists do it? One of your guesses might be using a telescope, and you would be right, but probably not in the way you think. Although optical instruments like the iconic Hubble Space Telescope have captured stunning images, there are many details they cannot see. Humans can perceive visible light waves, but there are other types of light on the electromagnetic spectrum that are invisible to us, like radio waves. Used in analog radios around the world and having a frequency between 3 kHz and up to 300 GHz, radio waves are the basis of radio astronomy. Celestial bodies naturally emit radio waves, which travel through space and can be intercepted by radio telescopes, most of which look like this. The radio waves hit the surface of the dish and bounce up to the tip of the telescope, the focal point, where they enter a sensitive receiver. The receiver amplifies the radio waves and converts them into a signal that can be stored in a computer. Astronomers can then turn this information into pictures, but how do they do that? I will use a simplified version of the data to explain the process. Let's call each of these squares a pixel. Each pixel stores information about the radio waves coming from a point in space. The pixel beside it stores information from the very next spot in space and so on. A radio telescope scans across an object and receives radio waves from each little spot in space around it. Some spots may have stronger radio waves coming from them than others. This information is stored in pixels that the computer turns into numbers. For example, if radio waves are weak at a particular position, a small number would be recorded. And if no radio waves were coming from that spot, the computer would assign a 0 in that pixel. After replacing the numbers with colors, a picture of the radio source results. In fact, the first image of a black hole ever was taken using radio astronomy. With that said, to obtain the same level of detail and resolution in their images as optical telescopes, radio telescopes have to be much bigger. However, unlike their optical counterparts, radio telescopes can be used even in cloudy days and travel through cosmic dust as well as detect invisible hydrogen gas, which is the most abundant element in the universe. So next time you're struggling with a sky photoshoot, try with a radio telescope and you might just get the perfect shot.